All right. Welcome everybody to another physics video lecture. Today we are going to be talking about free fall. All right. So let's jump right into it. What is free fall? All right. As I'm sure you can tell, free fall is when something is falling through the air. Okay. The physics definition of this is an object is in free fall if the only force it is feeling is the force of gravity, okay? Which means that something like an airplane would not be in free fall because it has a force that's pushing it up and forward, right? There's lift, there's thrust that's going on. A parachute wouldn't be in free fall because there's air resistance that's slowing it down. But anything that you throw into the sky, anything that we call a projectile that you're throwing up or shooting up or launching up, is in free fall as it's falling back down. Okay, so we're going to be looking at this today. Today we're just going to be looking at taking things, throwing them up in the air and seeing what happens to them. All right. Now we're talking about the force of gravity here for the first time. And what you need to understand is two things. Number one, gravity is a force that always points straight down to the center of the earth. All right, so that is the direction that gravity is always pointing, is straight down. And there's a number associated with this, okay? This is the acceleration due to gravity is always 9.8 meters per second squared straight down. And this is going to be true forever and all throughout class, which this actually makes things a little bit easier when it comes to gravity, as you might see. All right, so today we're going to be looking at equations. Today's a math day. So a big question is, what equations do we use for free fall? And the easy answer for this is we just keep using our acceleration equations, right? The only difference is that now when we're in free fall, because the only force we experience is gravity, the only acceleration we're going to see in any of these problems is always going to be 9.8 meters per second down, which actually makes these a little bit easier to deal with because we always know the acceleration. If it's up in the air, right? If you throw it up in the sky, the acceleration that that object experiences is always 9.8 meters per second straight down, okay? So before we get into it, let's look at these two pictures here, all right? When you drop an object, okay, because the acceleration is pointing down, that means as the object falls, its velocity gets bigger and bigger and bigger, right? It's accelerating down, which means that it's speeding up as it falls down, okay? That's important to remember, all right? Now in these pictures, the velocity points down and the acceleration points down. This is because we're just dropping the object. Whereas here, because we're throwing the object up into the air, okay, the acceleration due to gravity always points down. So when you throw the object up, right, if the acceleration is going down and the object is going up, what happens is the velocity of the object, as it's going up, the velocity gets slower and slower and slower until it gets to the very top. When it gets to the very top, its velocity is zero, right? I mean, watch, right? It stops right at the very top. It slows down, stops, and then since acceleration is pointing down, as it falls, it speeds up. Velocity increasing again. Okay? Again, the red arrows show the direction and magnitude. Again, magnitude just means the size of the velocity in each one of these examples. Okay? So again, when we throw the object up, okay, its velocity decreases because acceleration points down. So it's going up, it's slowing down, stopping, and then speeding up, accelerating as it goes back down. All right? The velocity points up when it's going up, down when it's going down, and the acceleration always points down. I wrote that there twice because it's important. So let's jump into this and knock out some problems, okay? So the first problem here is pretty straightforward. In fact, let me get a new marker. Okay, a ball is dropped off from a cliff. How fast is it going 5 seconds after it's released? Okay, So it doesn't seem like we have a lot of information, but if we think about it, we know more than we actually think we do, okay? So the only number I see here is 5 seconds, right? And 5 seconds is always going to be our time. But I actually know two other things. Number one, I know that we're dropping the ball. And whenever you drop something, you ask yourself, what is its initial velocity? Well, its initial velocity, if you drop something, is 0, right? It's not moving. So I know my initial velocity is 0 meters per second. And the last thing I know is I always know my acceleration. It's falling through the sky. So that means my acceleration is always 9.8 meters per second squared. And we are looking for how fast it's going. So that's going to be our final velocity. Here is my chart. I go over here to my equations. Which one has all four? Well, that would be 1. We got acceleration, final velocity, initial velocity, and time. I write down my equation. Acceleration equals Vf minus Vi divided by time. Plug in my numbers. 9.8 equals my final velocity minus my initial velocity divided by time. Oops. Divided by my time, which is 5. Okay. Bring this down again. This gives me 9.8 equals final velocity minus 0 is equal to Vf divided by 5. Right? All I did here was just Vf minus 0 is 0. I want the final velocity by itself. All right? So this is division. So we have to do the opposite of division, which is multiplying. 5 divided by 5 is 1. And this gives me my final velocity equals 5 times 9.8. Beep, boop, 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 boop. Gives you 49 meters per second. So this is kind of cool. If you drop something, and if you time it, you can use the stopwatch on your phone. Using this equation, by knowing how long it's falling, you can actually calculate how fast it's going, which is kind of fun. And somewhat useful, but not as useful. Sorry, guys. There it is. Oh, lost my eraser. But not as useful as the next little trick I'm going to show you. This next one is actually something you can use in real life. Okay, so now here we see that every second the velocity is increasing. At 0 seconds, the velocity is 0. At 1 second, it's 9.8. At 2 seconds, it's 19.6. And at 5 seconds, it's 49 meters per second. That's cool. But something you might be more interested in is how far it's fallen after 5 seconds, okay? So how tall is it? Okay, how tall is this cliff? So again, we're gonna write down what we know. We know the same things. We still know the time is 5 seconds. We still know our initial velocity is 0, and we know our acceleration is 9.8 meters per second squared. And now we're looking for how far it's fallen down. Well, how far something is the distance. Okay, so which one of these equations can we use? I put them down here because of this, but we can't use the first equation because we don't have a distance. Technically, we can use the second equation, but this one is kind of confusing because it has these squares in it. So we're actually going to use this equation right here. We're going to use this third one. Okay? So we're going to use this because look, distance equals VI times T plus 1/2 A times T squared. And we got all that. D, check. VI, check. Time, check. Acceleration, check. Time, check. Boom. Plug these numbers in. Distance is equal to 0 times 5 plus 1/2 times 9.8 times 5 squared. All right? Notice I put parentheses around these. You need to do that because you have to do multiplication before you do addition. PEMDAS, forever, right? So we go through here. 0 times 5 is 0. And 1/2 times 9.8 times 5 squared. Put this in your calculator. I like doing it all at once. I would go 5 squared first, times 9.8, enter, times, remember, this is the same as 0.5, okay? You put all of that into your calculator, and you will get a distance of 122.5 meters. This is kind of a cool trick. If you want to know how tall something is, you can literally stand on the top of it, drop something, and use your phone to time it. And then all you have to do is plug that time into this equation, because you know the same thing. You know the acceleration, you know your initial velocity is 0. So if you're ever wondering, if you're ever standing on the top of like a cliff or something, and nobody's underneath you that can get hurt, you can drop a rock, time it, and see how tall it is, which is kind of fun. Good? Good. All right, moving our way through. Got a couple more. Okay, just doing the equations today. Trying to make sure this doesn't fall on me. All right, so let's do this little double trouble one right here. A drip of water falls from the roof of a house. That means that drop of water had to be hanging, which means its initial velocity is 0. It hits the ground in 1.2 seconds. How fast was it falling just before it hit the ground? So we're trying to find our final velocity. And since it's falling, we know our acceleration is 9.8 meters per second squared. We've already seen one like this. Go ahead, pause the video, see if you can get the right answer. Pause. All right, you're back. Let's see if you got the right answer. VI, VF, T, and acceleration. We're going to use that equation right there. Acceleration equals VF minus VI divided by T. All right, this gives me 9.8 is equal to VF minus 0 divided by 1.5. We've been here before. Trying to find the final velocity. That means I'm going to get rid of this minus 0. This is division. I'm going to do the opposite, which is multiply. You always multiply by the bottom number of the fraction. 1.2 divided by 1.2 cancels out. Make sure I got my number right here. And this becomes blah, 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 blah. Oh, I switch these up. This gives me final velocity equal to 11.8 meters per second. I don't have my calculator on me, so I had to do these beforehand. Yeah, so you know that drop of water is going 11.8 meters per second, about 20 miles an hour. So it's going pretty fast. The second one asks, how far did it fall? Well, again, we're going to use a new equation. This time, we are looking for how far, which is a distance. So we know our VF here. Now, we could, again, we need to find distance. So we can't use this equation, there's no distance. We could use this one, but again, it's complicated. I think we should use this last one right here, because we have VI, we have time, and we have acceleration. So we're going to use this. Distance equals VI times T plus 1/2 AT squared. Again, pause the video, get the right answer, pause. You're back. Let's see if you got the right answer. Distance equals 0 times 1.2 plus 1/2 times 9.8 plus 1.2 squared. Beep, boop, boop, beep, boop, boop, boop. Crunch these numbers and you will get a distance of, remember this is 0, 7.1 meters. Did you get the right answer? I bet you did. Good job. All right. These are the types of problems that you usually see, okay? And they're in the easier side. But as always, I want to prepare you guys for everything. So we're going to do two big dog problems to make sure that we're ready, okay? And these involve shooting something up into the sky. When you're throwing it up, it becomes a little trickier because the object is going up and down. So now here, we have a bullet. A bullet leaves a gun with a speed of 500 meters per second, okay? So if you're shooting it, that 500 meters per second is your initial velocity. It's fired straight up into the air. What is the maximum height it will reach? Okay, so we're shooting a bullet in the air. It starts off going 500 meters per second. When it gets to the very top, when it's at its highest point, how fast is the bullet going? Very good. At the highest point, that bullet is not moving, right? The bullet gets shot out of the gun, it goes up, 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 and it stops at 0 meters per second. So we know that our initial velocity is 500, Our final is 0. We know that our acceleration is always 9.8 meters per second squared. And we want to know the maximum height. That is our distance. How high in the sky is it going? So again, we can't use number 1. There's no distance. And unfortunately, we can't use number 3, which is the one I like, because we don't know the time. So we got to use number 2. All right? So this one, you got to make sure that you write it down and do all the steps here. So acceleration equals final velocity squared minus initial velocity squared times 2 times the distance. All right? Plug your numbers in. 9.8 equals 0 squared minus 500 squared divided by 2 times the distance. We want this d by itself here. So what we're going to do is actually get this whole business out of the bottom of this fraction. It makes it easier. Okay? So I'm going to multiply both sides by 2 times d. 2d divided by 2d is 1. 9.8 times 2d gives me 19.6 times d equals negative 500 squared, right? Because 0 squared is just 0. I bring this down. This gives me 19.6d equals 250,000. 500 times 500 is 250,000. And again, I want distance by itself. This is multiplication. So I do the opposite, which is division. I divide by the other number, which is 19.6. Whatever I do to this side, I do to this side. 19.6 divided by 19.6 is 1. And 250,000 divided by 19 gives me a distance of 12,775 meters. Big dog problem. But not crazy, not impossible. Did you get the right answer? Good job. If you don't get it, go back, watch it again. Okay? Make sure you're writing these down. That's super important. All right, I got one more for you. Good? All right, one more for you guys. All right, the last one here is how much time does it take before it returns to its starting position? Okay, so now we're shooting the bullet in the air. We know it goes 12,775 meters into the sky. I want to know how long it takes to go up and then fall back down to where it started. So again, we know our initial velocity is 500. We know that the final velocity all the way up the top is 0. We know that the distance is 12,775. We know the acceleration is equal to 9.8 meters per second. So what else do we have here? What are we trying to find? How much time? Okay, so what we have to realize here is the time that it takes something to go up is the exact same amount of time it takes to go down. So all we need to do is figure out how long it takes to go up, and then we multiply that by 2, right? Up and down. We just got to find the up part. Okay, so we're looking for time. Well, let's see here. Well, time, it's pretty easy, right? I know VF, I know VI, I know acceleration. Let's not make this harder than we need to. Acceleration equals VF minus VI divided by our time to go up. Plug our numbers in. 9.8 equals VF minus 500 divided by T. Okay. Mr. Norris, what are you doing? That's a 0. Okay. I want T by itself, so we got to get T out of the bottom of the fraction. So we do the opposite. This is division. We multiply. Whatever you do to one side, do to the other. T divided by T is 1. This gives me T times 9.8 is equal to, this 0 goes away, negative 500. Okay. Technically in these problems, 9.8 is also negative because it's pointing down. So if you're like, why would we get a negative time? It's not. You don't always have to put it there, but in some instances you have to because it's pointing down, right? Okay. This T is what I want. So this is multiplication. I do the opposite of multiplication, which is I divide by negative 9.8. Okay, negative 9.8 divided by negative 9.8 is 0. And 500 divided by 9.8 gives me a time equal to 51 seconds. Now, if you wouldn't have made 9.8 negative, you would have gotten a negative time. And negative time doesn't exist. So if you ever see that, go back and say, oh, acceleration was negative. In some of these instances, it doesn't matter if you make the acceleration positive or negative, but in some of them it does. And for it going up and down, it does. Remember, this is just our time to go up. Okay? So we actually need to take our up time and multiply it by 2. So the actual answer is 120 seconds. Or 102 seconds. It takes 51 seconds to go up and 51 seconds to go down. All right, guys, and that is pretty much every type of free fall problem that you're going to see. Go through these, watch the video, write down the equations, write down the steps, try to solve them yourself. When you're doing the DOL, come back to these problems. All the problems you see on the DOL are going to be some version of what we just looked at, okay? As always, you can email me, find me for tutoring, let me help you out. You guys are going to do great. Have a good day.